I'll outline some of the project strengths that we've talked about previously through our technical challenges. So A, it is low cost. We've demonstrated that by the use of the Arduino products. It's real-time mapping of emergency services personnel location, so we have that real-time data to us right away. Gives easy coordination of resources. You can see where all your resources are. You can then coordinate them as you see fit. Determines when a person is in need of assistance. This is done both manually through the buttons and automatically through the accelerometer data, and gives greater peace of mind. And gives greater peace of mind when falls are more likely. So you're walking about, you're not likely to fall. But if you're a horse-mounted police unit or on the bike or something like that, you do have more likely to fall and become unconscious. Some of the weaknesses that we identified previously were the GPS signal, obviously being in the building, very hard. Communication range. Officer may not want to use the technology, as found in our interview with the police officer. Potential cost to ambulances during a false positive call out to assistance. Risk involved the security of information being sent across a wireless network. This can be mitigated using encryption, but we didn't see fit for this prototype at the time.
Our system is an innovative system. It is innovative because it is the first dedicated device and system to register when someone is in need of assistance and automatically alert the authorities whilst updating a map in real time. There are other devices out there incorporating GPS and accelerometer technologies. However, this is the first one to automatically update, alert and organise help for someone who's in need at their most critical time. There are also various applications outside of the emergency service industries for this device. For instance, the elderly, who are at high risk of falling over at home, handicapped people who may be unable to press a panic button and have the device automatically organise it for themselves is invaluable. And there's possibilities to extend it to surf life-saving applications. Also, one innovative thought that we've had is to extend the device's use to police dogs. The device would not need any further alterations in the current state. Police dogs are at high risk of running away from their supervisor whilst chasing a suspect, as they're much faster than their supervisor. So the technical data of which route they take will be useful in report rights, and also dogs can get hurt just the same as humans. So that could be implemented to dogs without having any alterations done. The objectives. As well as meeting all of our original objectives, we've extended past the supervisor requirements and objectives. First of all, the server handles multiple devices. Our original objective was to prove the concept with one device, but we've extended our server to incorporate 50 devices as a minimum, which a server would need to handle multiple devices if it was going to be implemented across the police force. Also, the database stores the officer's health records. This sort of information is invaluable when someone is in need. This will allow headquarters to radio ahead to the ambulance with the physical description of the person in need and their previous health records, so when the ambulance arrives, they can get straight down to locating the officer and helping him. Further improvements that we thought of to continue past the project in future years and adapt the system that we've currently made would be to automatically redirect on-duty officers to improve efficiency. Currently, the device signals back to headquarters, and headquarters will then organise the nearest units. The device could automatically redirect the GPS of nearby units' cars to the location of the person in need. This would bypass call centres, bypass headquarters, and get help on the way quicker. Also, we could further improve the system by increasing the personnel tracking to incorporate cars on the Google server map. And when certain officers get in the car, it will register on the map who is in which car, and also the officers could incorporate if they have suspects with them. This way, headquarters could simply look at the map and know instantly who is in the car and direct their services as required. Staircase tracking is a further improvement that we've thought of. Currently, the GPS is weak, so when an officer goes into a building, it loses signal. We could improve this by using the accelerometer to track how many stairs they go up and which floor of the building they'll be on. So if they are injured on floor 10 of a building, we will be able to instantly redirect assistance to the exact floor that officer's on, rather than having to search through the building to try and find them. Finally, pothole detection is an emerging field already. Our device incorporates GPS and accelerometer, which means it's applicable to this field. When the device registers that an officer has gotten into the car and feels a vertical jolt in the accelerometer data, it could leave a silent pin on the map. If enough separate devices register the same jolt at the same location on the server could automatically generate a report to the council to investigate that location.
Okay, now we're going to have a quick look at some of the management techniques that we employed to ensure our project was the success it was. Firstly, we defined the milestones that we needed to hit, such as the hardware design and software design, hardware and software development, individual modular testing, and then overall system testing. From this, we then developed our Gantt chart, which we reassessed in our weekly meetings. The weekly meetings, we went through the completed work that each group member had done previously, as well as their goals that they intend on meeting the next week. This was all done while overlooked by our supervisor. For all of our work, we then employed a self-auditing process in which at least one group member looked over the other group members' works to make sure that they all worked and were able to be incorporated nicely into the full system. All of our large-scale challenges we worked on as a team, such as the overall system design and other similar problems. Our group roles are split up as such. So I looked after our hardware research design and the overall control software. This was because I've spent many years dealing with all of our hardware that we sell at Dick Smith Electronics, where I work. James took over all of the serial parser software and uploading all of the information to the server, mainly because of his work that he's done at NextGen Networks. Grant was in control of our website as well as the overall server software and research. He did this as his computer systems engineer. This is a quick overlay of our Gantt chart. There should be a hard to read copy that you've got. Basically, we've got all of our tasks that we intended on achieving, as well as our start and finish times and who was assigned to complete them. There are some tasks there that you can see are split between the three of us, such as our deliverables for the project. And here's a quick overview of the budget for the device in its prototype phase. As you can see, the Arduino board itself is relatively cheap, whereas the wireless communication modules are quite expensive. It comes to a $370 cost overall per module, which is relatively cheap, especially given it's only a prototype.
We also did a study of the project's ethical implications. There were positive and negative implications of our project. The first being that this improves the police department's duty of care. The police department has a responsibility to ensure their employees are safe. Our device helps them increase that duty. There's also increased accountability for officer locations. If they're accused of being somewhere, our data will be able to prove or disprove that accusation. There's also increased accountability for the time of incidents. If an officer is shot or rendered unconscious, our device will be able to prove exactly what time that happened and where it happened, and this will be useful in the court of law. Also, this will increase the apprehension of suspects. The emergency service personnel network increases response times of emergency services, meaning that more officers can get to the required locations quicker, increasing suspect apprehensions. There were negative implications of the device as well. There are already concerns with the police officers about their cars being tracked everywhere, let alone their personal location being tracked everywhere. Two mitigations we thought of this was to possibly not transmit their locations unless they are genuinely in need of help, when they would want their location transmitted. Also, to ensure that there is an acceptable use contract and that there is a medium to resolve grievances if this contract is breached. This second negative implication was that there is potential danger to police informants. Informants are meant to be anonymous. If the police officer is tracked to meet their informant, corrupt officers may be able to work out this data, potentially endangering the informants. Also, this potentially discovers officers from going to the Internal Investigation Unit for corruption, as they know their corrupt counterparts may be watching. There's also risk of interfering with hospital equipment as transmission frequencies may overlap. There were also many positive social implications of our device. It reduces fatalities, reduces health expenditure because emergency ambulances can get on the scene quicker, treat wounds quicker, so they don't become such a major problem for the officer. It increases job satisfaction, as Grant mentioned, peace of mind of the officer, knowing that they're being monitored. Increases recruitment for new officers who will know they're being looked after. Increases community faith as response times have been increased. And reduces a loss in productivity because the officers were treated sooner, they can get back to the field sooner. There was a negative implication socially, and that's paranoia about being tracked. If the officer is being tracked, he may not want to be seen to visiting certain locations, and he may think twice slightly before acting sometimes. There's also project's cultural implications. One major positive one was that it improved comradeship between the departments because they will get better results from their more efficient, obtaining criminals more efficiently. Also, it may negatively have a cultural implication during prayer time. If an officer is praying, it may start to beep at them if they don't move quick enough, and that will upset them. Well, it has the potential to upset them. Also, there's a police hierarchy culture inside the police force. Obviously, people manning the call centre is lower in this hierarchy than sergeants out in the field. If the sergeant is being seen to do the wrong thing by the people lower in the hierarchy, it has potential to upset that police culture.
I'll go in a bit about manufacturing. So currently we only have a prototype at the moment. We'll be looking at manufacturing further down the track, a complete product. So one of the things we touched on quite early was about the actual design of the housing itself. Compared with police officers and ambulance officers, they may just need a light device that's nice and durable. Whereas with MFS and CFS, they require those heat-resistant materials to be used. We'd also incorporate a single PCB design. This reduces, obviously, design costs and production costs. And also would have to also have to look into continual technology upgrades. So we are using GPS and accelerometer. Further down the track, say 6 months, those technologies might become obsolete and something else would come in and replace them. So we need to consider that when we do design our final product. And this also gives us mass manufacturing reduction in costs, or there is a reduction in cost due to mass manufacturing. Also, from the marketing side of things, would be marketing this as a service, not just the product itself. So we'd be marketing the device, the software, as well as the ability for them to come back and say, hey, this isn't right, can we get this changed? And also the technology upgrades as well, they'd be implemented. We'd be outsourcing the manufacturing as well as sales. It'd be the three of us engineers doing it, and obviously management and sales aren't our degrees. And we also have the goal, our main goal is to incorporate this system into all the emergency services involved, hence the name network. So it would be a whole network of all emergency services, so everyone can see everyone else. And this, by spreading out to all emergency services, you have the ability for the CFS to call the police to close down a road, and you know straight away which road. So finally, ESPN, Emergency Service Personnel. It gives us the ability to connect people in need to assistance a lot faster than is currently used. Has the potential to save lives because we can get that help in straight away, and improves emergency service coordination. I'll now go through a quick demonstration.